Hello students, so we are meeting in the second video for this week's lecture. So now we are going to discuss about the two sample t-test assuming equal variances. So I told you in the earlier video that when it comes to Excel data analysis toolpack, we are given three choices. We have discussed as to uh, in which situations we are supposed to use the paired two sample two samples for means. Now we are going to look at the two sample t-test assuming equal variances. So let me give you an overview of this particular test. So a two sample t-test assuming equal variances is used to test data to see if there is a statistical significance or if the results may have occurred randomly. The reason why we are supposed to use the two sample t-test assuming equal variance is to test data in order to check whether there is a statistical significance or uh, whether the results have been occurred randomly. And this is one of the three tests available in Excel, and of the three, it's the one least likely to be used. So out of all three, this would be the least used ones because the reason is because in the vast majority of cases, the hypothesis testing, you don't know the population variances. So in the real life situation, since we don't know the population variances, we might, the possibility of we choosing two sample t-test assuming equal variances is really low. The situations where we are supposed to use this particular test is only in the situations where we are asked to assume that there is a equal variances in the two samples. Is it clear? So in the real life situation, such situations are very rare where you have equal variances because we are going to look at the population variances and we never know whether the variances are equal or not. So this test should only be used if you have been explicitly informed that the population variances are equal. So you are supposed to use this particular test only if it is explicitly informed to you that the population variances are equal. If you are asked to take an assumption as to population variances are equal and you are asked to do the t-test, you can go for this option. Otherwise, you have to go for the third option where you have two sample t-test assuming unequal variances. If you don't have this information, you should be running the other t-test where two sample t-test assuming unequal variances. So I hope the information given in this slide is clear for you. Actually, the gist is that you need to make sure that if in the given information, if a assumption is given only as to the population the population variances are equal, only we go for this test. Otherwise, we go for the third test where you have the two sample t-test assuming unequal variances. Okay. We'll move on how to do a two sample t-test in Excel assuming equal variances. So when it comes to the previous t-test where we looked at the paired samples, there we took the same subject studied in two different situations, but here we are going to look at two different samples assuming that those two samples have equal variances. So in this particular video, I'm going to show you one particular example where we are going to look at in a battery manufacturing company. They are going to compare the lifetime of the old battery set, lifetime of all batteries and the new battery that they have come up with the R&D. Okay, so you can have this data set entered in the key. So this is the data set. So the first step is that, so this is the data set, pause the video and start entering the data to your Excel worksheet. So you have old and new. Old means in all batteries what was the lifetime, and new batteries what is the lifetime. So we are going to look at whether there is a difference in between these two samples, right? So we look at what are the steps. The first step is type your data into the worksheet. Generally, you will have list in one column and another list in the second column. The t-test will allow you to compare the means from these two columns. So that's something general. Write the null hypothesis. How to state the null hypothesis. I know by now you have an idea as to how to state the null hypothesis. So here, for example, your null hypothesis might be the means are differently by a certain amount. So here the null hypothesis would be H naught would be, what would be H naught? Mm. Where you have the lifetime of all batteries, the mean, have this symbol, all, this would be the null hypothesis. So that means we are assuming that there is no significant difference in the lifetime of the two batteries. Okay, so step 3, click the data tab and then click data analysis. If you don't see the data analysis button on the toolbar, so I have told you in the earlier videos also, normally this data analysis toolpack will not be readily available. Let me share the Excel sheet. So I have already entered the data set. Otherwise, we have to waste time for that. No? So I have already entered the data set. I know by now when you are following the video, pause the video and enter the data set to your worksheet. So here the data analysis toolpack is here. Normally the data analysis toolpack is not readily available, so you need to have make it available by going to file, options, add-ins, and here and here you have to choose it and click OK. So I have made it available. Now we are going to do the t-test. So here we are, since we are asked to assume that the two samples have equal variances, we are going to choose t-test two samples assuming equal variances. Click OK. So variable 1 range would be all, variable 2 range would be hypothesize mean difference. We are assuming that there is no difference in between the old and new battery life cycle, and also you have to be mindful of something. The reason why they have inculcated this R&D in the research and development in the production of new battery is because in order to they need to make the lifetime longer of the new batteries. Clear? So here since I have included the labels in the selection of the variable 1 and 2, I am choosing labels. So I'm going to have the output here itself and click OK. So here you can see the variances are different, but we have assumed it to be equal. The reason is because the specific information was given in the example as to assume that they have equal variances. That is the reason why we have chosen this t-test two samples assuming equal variances. So we have 15 observations, pooled variance and hypothesized mean difference. We are assuming that there is no such difference in between the lifetime of the old batteries and the lifetime of the new batteries, and the degree of freedom it's 28 and the t-test. So what are the things that we have to look into? Here we have to look into these values. We are going to look at the t-stat value. This time, not like in the previous video, we are going to look at the t-critical one-tail value, because I told you we know the direction now. The reason why we are running this particular test is because in order to check whether the lifetime of the new batteries has been greater than the lifetime of the old battery. So there is a direction where we know that if there is going to be a difference, that particular difference would be the lifetime of the new batteries has to be greater than the lifetime of the old batteries. Clear? So that is the reason why we are going to choose T critical one tail, since there is a we are sure about the direction. And then we have to look at the p value. Which p value should we look at? So have you thought about as to which p-value you are going to look at? Is it one tail or two tail? So here also we have looked at the t critical one tail value, because there is a direction. We know the direction, and so here also we would be looking at the p-value, the one tail value. Okay, so when you look at the t stat value, it's minus 0.15, and the t critical one tail value is 1.70. So this is t stat value is less than the t critical one tail value. We look at as to how we are supposed to interpret these values now, by based on what is the decision rule. So let me share the lecture slides with you all again. So how to do these other steps? So we have followed the steps and we have taken the results. So here, step 1. Compare the alpha value you type into the two sample t-test assuming equal variances window to the alpha value listed in the output on the worksheet. If the alpha level in the output, so here it's the if the p value in the output is larger than the alpha level you choose, you will be unable to reject the null hypothesis. That means if the p value is greater than the alpha 0.05, that means we are unable to reject the null hypothesis. We'll look at what is our p-value. So here the p-value is 0.439, which is greater than 0. This is greater than, so this is greater than 0.05. So what does it means? We are unable to reject the null hypothesis. Now we are going to look at the t-stat values. Look at what is given in the decision rule as to step 2. Compare the t-critical value in the output on the worksheet with the t-value listed. If the t-value is larger than t-critical value, you can reject the null hypothesis. If the t-stat value that you are getting is larger than the t-critical value, you can reject the null hypothesis. There are two critical values, one tail and two tail. If you are not sure, so here we know how to take the whether it's the one tail value or the two tail value that we have to look into. So if there is a direction, so here we are going to look at whether the lifetime of the new batteries is greater than the lifetime of the old batteries. So there is a direction. Okay, so that's the reason why we have looked into one-tailed t-test, one-tail critical value. So here the point is that if the t-stat value is greater than or larger than the t-critical value, you can reject the null hypothesis. But we'll look at what was our uh, was our results. So the t-stat value, is it greater than the t-critical one-tail value or is it less than the t-critical one-tail value? It's less than the t-critical one-tail value. That means, are we in a position to reject the null hypothesis? No, we can't reject the null hypothesis. That means based on these two values also, since the t-stat value that we have got is less than the t-critical one-tail value, again we are getting the results as to, we are getting the conclusion as to we are unable to reject the null hypothesis. Okay, so that means at the end the real conclusion is that by looking at the t-stat value and the p-value, we are not in a position to reject the null hypothesis. That means we are accepting the null hypothesis. That simply means that what was our null hypothesis? Here I have stated the null hypothesis, where the battery lifetime of old is equals to battery lifetime of new. So that means there is no significant difference in between the lifetime of all batteries and the new battery. So that is the conclusion that we derive into based on the t-test that we have run assuming equal variances. So I hope it's clear. So do this question again and again so that you would be having an idea as to how to derive the conclusion. Okay, so we'll meet in the other video with regards to how to run the t-test assuming unequal variances, which is the most commonly used technique or the tool when it comes to the data analysis tool pack t-test.